All right, welcome everyone to the first day of Prealgebra. We hope you guys learn a lot during your 3 weeks here. And so, first I'll just give a short explanation of what exactly AMC8 is, and why it's important, and why is what you're learning important. So AMC8 is a math competition that you'll commonly do in middle school, although I believe you can also do it in 4th or 5th grade if you figure out how to. And so it's a 25 question multiple choice test that you'll do over 40 minutes. And it covers a variety of different topics: algebra, geometry, number theory, basically all the topics we have in this course. So this course is basically just going to prepare you for AMC8. And if anyone has any questions, you can at any time just ask them in the chat, or you can even unmute and say them. All right. And we'll also introduce ourselves. So hi, my name is Yolanda, and I'm one of the teachers for Prealgebra.
Hi, my name is Gopal, and I'm also one of the teachers for Prealgebra this week.
And hi, I'm Kayung, and I'm the last teacher. Also, sorry to interrupt, but I'm pretty sure there are some people who are still in here that aren't supposed to be. So, I'm just gonna try to read the name of the people who are supposed to be here, and if you're not on that list, then you should double check which class you're supposed to be in. So, sorry if I pronounce any of these wrong, but we're supposed to have Aishwarya, Akshat, Brati, Kaure, Diraj, Gari, Hannah, Hashir, Jivitesh, Jyoti, Prima, Rama, Sanvi, Sai, Samyukta, Sarayu, Sanya, and Udip.
It's Udip.
Oh, sorry. But if you weren't on that list, then that means you're not in the right class. And that was off of Google Classroom. So if you go by a different name, then please tell us.
All right, so let's go ahead and get started. Okay, Shrita. And our first topic is going to be prime factorization. Okay, so what are factors? Factors are also known as divisors of a number. So basically, they're the numbers that divide another number. 5, it would be a divisor of 10 because 5 divides 10 into 2, and that is a whole number. 6 is not a divisor of 9 because 6 divides 9 into 1.5, and that's not a whole number. So it must divide the number into whole numbers. And so what we're going to do first is cover some divisibility rules.
So if a number is divisible by 2, that means that the number is even, or that it ends in 0, 2, 4, 6, or 8. If a number is divisible by 5, that means it ends in 0 or 5. And if a number is divisible by 10, that means it ends in a 0. So you guys probably already know most of these.
So for numbers 3 and 9, if a number is divisible by 3, then the sum of its digits is also a multiple of 3. So we'll see what this means. So in the chat, type if 4,958 is divisible by 3. And you just add the digits and then see if it's divisible by 3. So we see some answers. And the correct answer is no, which is what most of you guys said. Good job. Because 4 plus 9 plus 5 plus 8 is 26, which isn't a multiple of 3. So we'll do another one. Type if 282 is divisible by 3. Yeah, so a lot of you guys are saying yes, which is correct, because 2 plus 8 plus 2 is 12, which is a multiple of 3. And for the number 9, it's pretty similar. So if the digits sum up to a multiple of 9, then it's divisible by 9. So we'll try out. Type if 2196 is a multiple of 9. So we're seeing a lot of yeses. And you guys are right, because the digits add up to 18, which is a multiple of 9. So for 4 and 8, if a number is divisible by 4, then the last 2 digits will be divisible by 4. So this doesn't matter, like no matter how long the number is, only the last 2 digits matter when we're looking at divisibility. So for example, 1328 ends in 28, which is a multiple of 4, meaning that the entire number is also a multiple of 4. So in the chat, type if this number you see on the screen, 29,592 is a multiple of 4. So we're seeing a lot of yeses. And yeah, you guys are right, because it ends in 92, which is a multiple of 4. So the whole number is a multiple of 4. And for 8, it's also similar to 4. And this time, look at the last 3 digits. And if that's divisible by 8, that means the whole number is. So for example, 1,400 ends in 400, which is divisible by 4. So type if that number you see on the screen now is divisible by 4. Sorry, my voice is like dead. So we're seeing a lot of yeses. And yeah, you guys are right once again.
So for a number to be divisible by 6, it means that it's going to be divisible by both 2 and 3. So that means it ends in an even number, like 0, 2, 4, 6, or 8, and the sum of its digits is also a multiple of 3. So let's do an example. In the chat, type if 3048 is a multiple of 6. Okay, so for the most part, we're seeing yeses. And yeah, it is. The number ends in an even number 8. And it's also a multiple of 3 because 3 plus 0 plus 4 plus 8 is 15, which is a multiple of 3. And since it fulfills both requirements, 3048 is a multiple of 6.
All right, moving on to the rule for 7. So what you do here is you take away the last digit of a number, then you double that. Then you subtract that doubled number from the rest of the original number. And if your answer is divisible by 7, the original number is also divisible by 7. If your answer is 0, that also works. So is 189 divisible by 7? All right, this might have been a little bit confusing because we didn't have an example, so let's just go through and explain. The answer is yes, because what you do is you take away the last digit, which is 9, then you double 9, and that equals 18. Then you subtract 18 from the rest of the number. So what's left over is another 18 in the original number, and 18 minus 18 equals 0. Since 0 fulfills the criteria of being divisible by 7, then the original number 189 is also divisible by 7.
So what is a prime number? Now that you guys know what a factor is, we're going to look at what primes are. So a prime number is any number that has only 2 factors, 1 and itself. So for example, 17 is a prime number because the only factors it has is itself, 17, and 1. And 15 is not a prime number because it has more than 2 factors. So 15, 5, 3, and 1 all divide 15 into a whole number. So that's more than 2 factors, meaning it's not a prime number. So on the left, you can see a graph with prime numbers less than 100. So 2, 3, 5, 7, 11, 13. So the numbers highlighted in yellow are prime numbers. So we'll give you a second to look at that. And a common question that comes up is 1 a prime number? And some of you guys are saying in the chat that it's not, which is correct. So 1 is not a prime number because it only has 1 factor. And prime numbers have to have 2 different factors, so 1 and itself. And we're going to do a few problems about prime numbers, so ask any questions you have right now or while we solve them. So our first question is 91 a prime number? Type in the chat. So we are seeing a lot of no's, and you guys are right.
All right, like Gopal said in the chat, what 2 numbers are 91 divisible by?
Yeah, so we'll see. And yeah, 7 times 13 is 91. So it's not a prime number. And then is 101 a prime number? Also type your answer in the chat. So we see a couple of yeses, which is correct. So 101 is a prime number because it only has factors of 101 and 1.
So now we're going to move on to prime factorization. And so basically what prime factorization is, it's where you find the prime factors, it's where you find the prime factors of a number that multiply to become that number. And this may seem like a confusing definition, but since each prime factor only has a factor of itself and 1, each prime factorization is actually unique to that number. So for example, like we can take a random number like 2022 and find the prime factorization of it. And here we do something called the factor tree, where we divide it by prime numbers, and we continuously divide it by these prime numbers until we get a complete prime factorization of only primes. So for example, here the prime factorization would be 3, or would be 2 times 3 times 337. All right, and we're going to go through some more examples so that you guys actually understand this, because this is one of the more fundamental parts of it's one of the more fundamental parts of counting, like number theory in math counts and AMC 8. So find the prime factorization of 2020. I think we're supposed to find the prime factorization of 2023, or sorry, 2021. Find the prime factor.
Okay, yeah, everyone find the prime factorization of 2021. There was a small mistake in the slides ahead, but don't worry about that. We'll get to it when we get there.
Make sure to use a factor tree. The rule for 7 is where you take the last number, like the last digit of the number, and then you double it and subtract it from the number that came before it, or like the digits that came before it. And then you see if that number is divisible by 7.
Ignore
And
2023. That should be
so-
2021.
Yeah. But yeah, it's going to be 43 times 47. And this one was actually a pretty hard first example because you'd have to go all the way, you'd have to check all the numbers all the way until like 43, right? Because it's not divisible by any of the numbers before. So this one was actually pretty tricky. We can, let's do, this one will probably be a little more easier for you guys. Yeah, you guys can use exponents to represent. You guys can use exponents to represent the different numbers. So we're going to do the prime factorization of 2025, and make sure to use a factor tree, and make sure to use a factor tree.
Okay, so the answer is 3 times 3 times 3 times 3 times 5 times 5. I'm pretty sure I saw some of you getting that, so good job.
Yeah. I saw a few of you put 405 times 5, and right there you need to make sure that 405 is actually prime. And if we look at our divisibility rules, 405 is actually divisible by both 3, or just divisible by 3, 9, and 5. So just make sure that when you're doing the factor trees that you make sure that every number that you get in the prime factorization is actually prime.
Oh wait, I'm confused since like
Mhm.
when you do the prime factorization of 2025, first you can make it divisible by 5 and 45.
Yeah.
Wait, or does the second number have to be prime?
You can actually, the good thing about this is that if you, for example, if we do 2025, like I can open up a whiteboard and I can show you. But if we
Sorry.
do 2025, you can do it. You can divide 2025 by 5 and then get 405 on the other side, or like the other factor, right?
Oh, okay, I see.
And then you can divide that one by 5 again and get like 91, or not 91, 81. And then you can divide 8 by 3, and then you'll get 27.
Space, and then I think you
Oh,
get.
I see. I made a mistake. Okay.
Yeah, but any way you do it, like any of the factors, the way you, it doesn't matter what way in which you like factor it, like what numbers you get, you'll have the same prime factorization at the end of every method.
All right.
Yeah, okay, that's fine.
All right, Aksha, we're gonna go ahead and talk about exactly what you're saying. So 3 times 3 times 3 times 3 times 5 times 5 is a very long way to write out the prime factorization. So instead, an easy way to fix that is just to use exponents. Exponents are written using x to the power of b. So the exponent is like a smaller number that's above the base. And the b is used to show the number of times x is multiplied by itself. So for example, 3 to the 4th would be used to signify 3 times 3 times 3 times 3, because 3 is being multiplied by itself 4 times. and then 5 squared, or 5 raised to the power of 2, would signify 5 times 5. So instead of writing this out like this, you can write 3 to the 4th times 5 squared. Okay, so now you should try to find the prime factorization of 2023. Okay, the answer is 7 times 17 squared. So good job if you got that. And so we're going to draw a factor tree to help us solve this problem. So this is what it looks like. So first we divide 2023 by 7, because knowing the divisibility rule, we do 3 times 2, which is 6, and then subtract 202 minus 6, which gets us 196, which is divisible by 7. And then that gets us 289, which can be divided into 2 primes, 17 and 17. And then we write that out like this. So you can write 7 to the power of 1, but you don't need to. That's just extra because it's just the same thing as not writing an exponent at all.
So we're going to do some more practice. And we have, I think, 5 questions. So you guys have about 6 minutes to solve these. And once you do, you can put them in like one message and type it in the chat.
All right, everyone, you can wait until you've solved all 6 and then just post them in one comment.
I think if you press enter to try and like make a new line, it might send your message. So just type it all in like a row. Yeah. So that's what happens. So someone in the chat said that you can press shift and then press enter to have your answer go down a line without sending your answer. So if you guys want to do that. Oh, it worked for me. So you have to hold shift and then press enter. Okay.
Yeah, I don't think it works on a Mac. But anyways, you guys have 3 minutes left, okay? So finish up if you can. And don't worry if we don't get through all of them, but just do your best.
Yeah. So let's go over the answers really quickly. So the first one was 1,245. And so if we look at this one, we would start out with, so you can see that it ends in a 5. So you can take out a factor of 5, which would give you 5 times 2,249. And then you could see that 249 has a factor of 3. So that would make it become 3 times 83. And your final answer would be 3 times 5 times 83. So I saw a lot of you guys had just 3 times 5. And so one important thing to think about is you have to find, so you're not trying to just find factors that divide into this number. You have to find like all of the numbers that multiply up to this number. So you can't just forget some of them. So when you draw a factor tree, so it would have, yeah,
Try now.
doesn't work.
Oh, okay, try now.
Okay, so let's see. Okay, so I'm trying to draw something on the screen with my mouse, so don't mind me if it looks really weird. But so first you would take out your 5, and then you would be left with 249. And you would have to factor this again because that's not a prime number. So you take out your 3, then you're left with 83. And after a bit, you would probably realize that 83 is a prime number. So you stop here, but you have to include all of these factors that you're left with at the end. So these 3 factors multiplied would be your prime factorization.
All right, let me
So it's okay if you guys messed up because this is just practice. So you'll have more practice. So for 1776, you would take out your 2, and then, so there was actually 4 factors of 2, which is 16, and then your 3, and then 37. So those are your prime factors. So I see a lot of you got that one. For 387, so you take out your 3, then you take out another 3, and you're left with your 43. So it's 3 squared times 43. And make sure you don't forget the exponents when you write them. And then for 9,583, you would first take out your 7. And then after a bit, you might realize that 1,369 is actually a perfect square. So 37 squared is 1,369. And whenever you guys do this, so when you're trying to find the prime factors that divide into these numbers, you can use the divisibility rules. So that's how you would find some of the factors easily. And then lastly for 40,320. So for some of these smaller numbers, you might not need to create a factor tree, but for bigger numbers like this one, you definitely should make one because it's really easy to make mistakes if you don't. So if you see this big factor tree, we are going by steps. So you keep taking out your factors until you are left with only prime factors that you can't divide anymore. So this one is a bit long, so we'll give you a second to look at it. But the answer is 2 to the 7 times 3 squared times 5 times 7. And I see some of you got that in the chat, so nice. That was a harder one.
All right, so now we're going to move on to greatest common factor and least common multiple. And so the greatest common factor is basically it's just the greatest number to divide all the given numbers, like in a question. So for example, if they ask you what the greatest common factor of 25 and 60 is, the biggest number that will divide both 25 and 60, that's going to be 5, right? And a hard example would be like the greatest common factor of 150, 270, and 330. This is going to be 30 because 30 is the largest number that divides all 3 of these numbers, 150, 270, and 330. And okay. So now the least common multiple is going to be the smallest number that is divisible by all the given numbers. This one isn't going to be a factor of the numbers. The numbers that are given are actually going to be a factor of this. So for example, the least common multiple of 25 and 60 is going to be 300 because 300 is the smallest number that is divisible by both 25 and 60. And then the least common multiple of 150, 270, 330 is going to be 14,850. And this is because 14,850 is the smallest number divisible by 150, 270, and 330. And you're going to learn a way to do these questions, because there is a method involving prime factorization to solve these questions.
All right, so like Gopal said, this is how to find the greatest common factor. So if you're going to find the greatest common factor of two numbers, first you must find the prime factorization of both of those numbers. And then you look for what prime factors are shared between those two prime factorizations. Those prime factors will multiply out to become the GCF. Okay, so let's go through an example to further illustrate what that means. And also this can be applied to more than two numbers. So if you're finding the greatest common factor of like three numbers, you just find the prime factorization of all of those and do the same thing. So here, greatest common factor of 231 and 497. So the prime factorization of 231 is 3 times 7 times 11. And then 497 is 7 times 71. So looking at those, which prime factor is shared between those two prime factorizations, okay? Write your answer in the chat. And yeah, there will be some questions in this slideshow that might require a calculator. Otherwise, it would take you forever, but we'll let you know when those questions are coming up. So good job, everyone that says 7. 7 is the only shared prime factor here. So that means that the greatest common factor of these two numbers is 7. And another example, find the GCF of all of those, 1,095, 9,300, and 2,835. So first step is to find the prime factorizations of everything, and you can see them there. All right, now type in the chat which prime factors are common between all three of those, okay? They must be present in all three. Okay, great job, everyone who said 3 and 5. Those two are the only shared factors between all three of those numbers. So the GCF would be 15. 3 times 5, 15. Okay. If anyone has any questions, ask them now, or we'll move on to finding LCM.
Oh, why would you do 3 times 15? Like, sorry, there's a lot of background noise. Why would you do 3 times 15 since there's like 5 in all of them? And
Okay,
what
what you're supposed to do is you're supposed to do 3 times 5. Because you can see there's a 3 in all of the prime factorizations, and then there's a 5 in all the prime factorizations. So then you multiply those two, 3 times 5, to get the greatest common factor of all three numbers. We're not multiplying anything by 15, so maybe,
okay.
Yeah, okay.
So next we're going to look at how to find the least common multiple. And to do this, you also take the prime factorization of the numbers. And so you list all the prime numbers, and then so you list all the prime numbers found. The most often they occur for any one given prime. So that might sound a little confusing, but we'll go through some examples. And then you would multiply these together to find the LCM. And somebody asked if we are going to send these slides. So yes, after each class, we will share recordings and also slides so you can look back. So the first example is to find the LCM of 231 and 497. So here are the prime factorizations of these two. And when we did the GCF, you found the one that's in common. So right now we're kind of doing the opposite. So every prime factor that comes up, you have to multiply, and you have to multiply each of them by like their biggest exponent. So here the numbers that occur are 3, 7, 11, and 71. So this might sound a little confusing, but basically you would do 3 times 7 times 11 times 71. And 7 is in both of these, But since they're both raised to the power of 1, you would just raise the 7 in your answer to the power of 1 too. So if we look at the next example, you can actually see one where you take the highest exponent. So this one, you can see the first one is 3 times 5 times 73. The second one is 2 squared times 3 times 5 to the second, and then times 31. And the last one is 3 to the fourth times 5 times 7. So we first have to get all of the prime factors that are shown on here. So you would take 2, 3, 5, 7, 31, and 73. And for each of these, you have to raise them to the highest power you see on here. So for example, for the number 3, in the first number and the second number, they're both raised to the power of 1. But in the third number, it's raised to the power of 4. So then in your answer, your 3 would be raised to the power of 4 because that's the highest exponent you see in any of these numbers. And for the 2, you would raise it to the power of 2 because that's the highest exponent. For 5, you would raise it to the power of 2 because if you look in the second number, you can see that 2 up there. And then for 7, there's only 1, so it's raised to the power of 1. And then 31, same thing. 73, same thing.
Would you simplify it right before you multiply all the numbers together?
What do you mean by simplify?
As in, like, 2 to the power of 2 becomes 4, 3 to the power of 4 becomes whatever 3 to the power of 4 is.
So if you want to solve this one, it might be easier to have a calculator because now that you have all your prime factors, all you need to do is multiply. So if you're doing it by hand, then yeah, you can like simplify and then multiply. But it would probably be helpful to have your calculator because as you can see, the answer is a really big number.
Okay.
So now we're going to look at one of the common properties of least common multiple and greatest common factor. So the greatest common factor of two numbers, you can say A and B, the greatest common factor of A and B multiplied by the least common multiple of A and B is going to give you the result of A times B. And so basically, we're going to use this property to solve a few problems. So the first question is to find the least common multiple of 90 and 81, and use the property that was given above. Not quite. It's not quite 7,290. So remember our property of the greatest common factor of A and B times the least common multiple of A and B is going to be equal to A times B. So basically, it's 810. And this is because our greatest common factor of 90 and 81 is going to be 9. And then our least common multiple of 90 and 81 is going to be equal to 90 times 81 divided by the greatest common factor, or 9. And so this is going to just be equal to 810. I used a calculator for that. Is it? I guess that's fine. All right, and if the LCM, or the least common multiple of x and y, is 13, and the product of x and y is 247, find the greatest common factor of x and y. And this one's almost a direct application of our property. Okay. So yeah, I'm seeing that people are saying 19. And yeah, the answer is 19. It's going to be, remember, our property is the greatest common factor times the least common multiple is going to be equal to the product of the two numbers. So, and it gives us the product of the two numbers as 247 and the least common multiple as 13. So 13 times the greatest common factor is going to be equal to 247. And if we divide 247 by 13, we're going to get our greatest common factor, and that's going to be 19. Okay.
Okay, so here's our first practice problem. Find the GCF and LCM of 576 and 336. You can use a calculator. And just so you don't get confused, this one doesn't use the properties that we were going over on the last slide, but what you should do is find the prime factorization and then use some of the other rules we learned. Yeah, you can put your answers in the chat when you're done. All right, nice job. The greatest common factor is 48, and the least common multiple is 4032. So how do we find that? Well, first, we take the prime factorization of both numbers. And to find the greatest common factor, remember we have to look for which ones are common between those. So you can see that both have 2 to the 4th in them. This one has 2 to the 6th, but this one only has 2 to the 4th. So only 2 to the 4th is shared. And then both have a 3. So then we multiply those. 2 to the 4th times 3 equals 48. Now for least common multiple, we do the opposite of that. So we take the greatest exponent for each of the factors. So for 2, the greatest exponent is 2 to the 6th. So we take that. For 3, that would be 3 squared. So we take that. And then finally there's 7. Then we multiply all of those and we get an LCM of 4032.
So this problem, find the LCM of A and B given that the GCF is 16 and the product of A and B is 1/4 of the square of the LCM of A and B. So this problem uses some algebra, and we'll learn how to solve equations next class. So if you don't exactly know how to do that, then that's okay for now. But if you do, then try to solve this one. So we see a couple of 64s, and that is the correct answer. So we get this by first writing out the property that we just learned, where the GCF times the LCM is A times B, so the two numbers multiplied. And we can substitute 16 for the GCF because our problem tells us that the GCF is 16. And then on the right side, we can substitute the LCM of A and B squared divided by 4, because our problem also tells us that the product of A and B is 1/4 of the square of the LCM of A and B. So once you get this equation, you can just solve it by dividing both sides by the LCM and then multiplying both sides by 4. And once again, if you don't know how to solve equations like this, we'll learn it next class, so don't worry.
Okay, so problem 3. How many positive integers less than 100 are multiples of 2, 3, and 5? Okay, so I'm seeing a lot of 3s, and yeah, the correct answer is 3. And this is because the LCM of 2, 3, and 5 is going to be equal to 30. And then, yeah, 100 divided by 30. So like so 30, 60, and 90 are going to be your three numbers. So 100 divided by 30 is going to be 3. Yeah.
Okay. Mrs. Chandler has a class of 20 kids, and she wants to give each student at least one pencil to use. Pencils are sold in packages of 12. If Mrs. Chandler wants to give each student the same number of pencils with no extra left over, what is the smallest number of packages she could buy? Okay, the correct answer is 5. And remember, she wants to give each student the same number of pencils without any extra left over. So this question basically asks you for what is the LCM of 20 and 12? Well, the LCM of that would be 60 pencils. And then because 60 would divide both 20 and 12 with nothing left over. This fits her criteria. And so 60 pencils, we're buying 60 pencils with 12 pencils per box. That means we must buy 5 boxes. So good job, everyone. I don't think, would you want to use a broken pencil? I don't really think so.
So our next problem is this. Buns are sold in packs of 12, hamburger patties are sold in packages of 8, and veggie burger patties are sold in packages of 10. So if both hamburgers and veggie burger sandwiches are served and there are no extra buns, hamburgers, or veggie burgers, then what is the least number of sandwiches that could be served at the picnic? So you can't have any buns or any patties left over. So I saw a lot of 120s in the chat, but the answer is actually 36. So we'll go over how to do this. So if we have at least one of both veggie and hamburger patty packages, we must have at least 18 burgers. This is because if you open both of those packages, one of them has 8 and the other has 10, so you'll have to have at least 18 burgers since you can't have any left over. And then also we must have a factor of 12 buns. Yeah, that's not patties, buns. So we would find the least common multiple of those two numbers, which would be 36.
Okay. Johnny had a full bag of apple seeds. He found that if he repeatedly removed the apple seeds 2 at a time, 1 seed remained in the bag at the end. Similarly, if he repeatedly removed the seeds 3, 4, 5, or 6 at a time from the bag, 1 seed remained in the bag at the end. What is the least number of seeds he could have in the bag? Yeah, so the answer is going to be 61. And this is because the seeds are going to be in, the number of seeds is going to be 1 more than the least common multiple of 2, 3, 4, 5, and 6. And so the least common multiple of 2, 3, 4, 5, and 6 is going to be 61 or 60. And then you add 1 more because there's a remainder of 1 at the end of the bag. So the answer is going to be 61. It's the least number of seeds in the bag. Are there any questions about this?
All right, so we're going to skip over this problem because it kind of requires some stuff you haven't learned yet. And plus, we want to get to the more fun activities at the end.
Yeah, but we'll go over this last question. So the least common multiple of A and B is 12, and the least common multiple of B and C is 15. So what is the least possible value of the least common multiple of A and C?
They use the word least so many times.
Sorry, forgot to put the answers up. You have a few options.
So you can write the letter or the number answer. So yeah, I see some 20s in the chat. And that is the correct answer. So A, 20 is correct. Because first we noticed that B is in both of those LCM values they give us, which means that B has to divide both 12 and 15. And the only number that divides both of those is, is 3. So then that means B has to be 3. And we want the least possible value. So we set A to 4 and C to 5 so that they meet the criteria and they're also the least value possible. And that means the LCM of A and C is 20. So we're going to have a short 5-minute break, and you guys should come back to your computer after this timer is over.
If you have any questions about one of the previous concepts, you can also ask right now, and we can go over that.
I was wondering, it's not about this specific class, but for the next class, is it the same Zoom link or will they just post another one?
So for this week, in this pre-algebra class, you're going to be using the same link, but next week and the week after that, you will go to a different class, so then you'll have a different link.
All right.
All right, let's go back to
someone asked if you could explain the 7 rule again.
No,
Yeah.
let's just go to this slide because oops.
No, someone restarted the. All right, it's okay.
We'll just say 1039. Okay, we'll use this slide and we can annotate. Okay, so let's just give an example problem. Let's see. Okay, 504, is that divisible by 7? So the first step is to take this last digit over here, the last digit of the number, and you have to multiply that by 2, or basically just pretend like you're chopping it off from this number and you're multiplying it by 2, and that gets you 8. And then you subtract 8 from the rest of the number over here, so 50 minus 8, and then that gets you 42. Now you ask yourself, is this number that you got right here, is that divisible by 7, or is it 0? And if either of those is true, then the whole number, 504, would be divisible by 7. So since 42 is 7 times 6, we know that 504 is divisible by 7. All right, does that make sense?
Oh, and one thing to add, the number you get after you subtract can also be negative, but you would just see if it's a multiple of 7, but just negative.
Let's pretend like the timer should be right here and just continue. Okay, maybe it should be more like this because we do have a lot of stuff we have to cover still.
Yeah.
Okay, break is over. Let's continue. All right, on to our activity. So we have a couple of different Kahoots, and we're going to see how much we can get through, and we're going to see how much you know. Okay, so let's start with divisibility rules. Oh dang it, you come up. Okay.
Right. If you don't say something, it's pretty simple. Okay, hopefully everyone does.
All right, go ahead and join.
So for Kahoot, there's not really like a link. You go to kahoot.it, spelled with the K, and you put in the pin that you see on the screen.
All right, let's vote, guys. Do we want the music or do we not want the music? Because I know some people hate it, some people like it. Music. All right, let's leave it on then. Okay, is anyone not in the Kahoot that wants to be in the Kahoot? All right, because otherwise we're gonna go ahead and start. I think you can still join after we start, probably. Yeah, okay, so let's go ahead. All right, nice job. 4,624 is divisible by 4, because if you look at the last two numbers, 24, that is also divisible by 4. All right, good job, everyone. Okay, this one is a bit tricky. Remember, the rule for 6 is that it must follow the rules for both 2 and 3. So you can see the last number is an even number, so it's definitely divisible by 2. But let's say for 3, 5 plus 9 plus 1 plus 2 equals 17, which is not divisible by 3. So then this number is not divisible by 6. All right, nice job, Diraj. All right, the answer here is yes, because 2 plus 5 plus 2 is 9, and that is a multiple of 9. So the whole number is divisible by 9. All right, good job. We did very good on that one. Okay, the answer here is just 2. So let's see, some of you guys put 2 and 3. So 7 plus 2 plus 2 equals 11, and that is not divisible by 3, so the whole number is not divisible by 3. All right, good job. The answer is 4. Okay, so here you know that it is definitely not divisible by 6 because this last number here is this number is an odd number. And if it's divisible by 6, it must be divisible by 2. So this would have to be an even number. Okay, very nice job, everyone. All right, 2 and 4. Sounds like a lot of you guys misclicked, so I'm guessing those are the odd ones.
Yeah, I just contacted her and I understand what this That's a huge amount of work that they need a whole screen to do the work. Is that a big work?
If you just said something, sorry, but I couldn't hear that, so might be better to put it in the chat if you were talking to me. All right, so 1,212 would be divisible by all of those because, yeah, just know the divisibility rules. It's divisible by 4 because 12 is divisible by 4. It's divisible by 3 because the digits sum up to 6. And yeah, if it's divisible by 2 and 3, then it's definitely divisible by 6. Nice job, both 3 and 5. All right, here are the winners. Great job, Sandy. Wow, 11 out of 11. Great job. And good job. All right, looks like you guys all have divisibility rules down very well. Congrats to the runners up as well. And we are going to go to the next Kahoot, which is, oh God. Okay. Let's see here. And Kayang will lead you guys through this one.
We'll give you a couple of more seconds to join since we have like 18 students. Is that everybody? Okay, it seems like it. So I guess we can start.
All right, if you haven't joined, you can join in later. In the middle if you need to.
I feel like the time limit might be a bit too long.
Okay, yeah, I should just like skip them.
Yeah, so the answer is 11 times 2 to the third, and most of you got that. Good job. One hint is that there might be 2 right answers. So if you're getting confused about that. Yeah, I know it was a very helpful hint. So both of those are right. So you can write them out or write it in exponent form. But yeah, good job. I think we can like skip it after 12 or 13 people. So this one is 2 to the 4th times 7 times 5. And so one of these, the blue one, you could have eliminated it right away because 4 isn't even a prime number. So the answer for this one was the red one. And for bigger numbers like these, especially, you should probably draw out a factor tree on like a scrap piece of paper. So if you guys want to get some like paper and a pencil or something, that would be helpful. So this one, a composite number, if you don't know what that is basically numbers that aren't prime numbers. So like 6 has factors of 1, 2, 3, and 6. So that would be a composite number. So, and every composite number can be expressed as a product of prime numbers. So every number doesn't have a unique prime factorization. That would be false. So every number does have a unique prime factorization. Yeah.
It looks at least different.
So 59 is actually a prime number. And one thing to note is prime numbers can't have decimals or fractions. So they have to be whole numbers. So the answer is 2 squared times 5 squared. And some people collect red, and 4 times 25 is 100, but 4 isn't a prime number. So you would have to break that into 2 2s. So yeah, it's 2 to the third times 17. And red and green, which almost none of you picked, can't be the answer because one has 8, which isn't prime, and one has a decimal.
Okay, I'm gonna skip now. Okay, insert if you have an insert.
Oh, so some of you might have noticed right away that this is actually a perfect square. So 13 squared is 169. And it's not prime, so yeah. So yeah, 181 is a prime number, and some of you guys are pointing out that green has a +1, and you can't add anything in a prime factorization. You can only multiply. Yay, good job, everyone got it right. Good job, guys. This one was very similar to the last one. So 157 is indeed a prime number, and you can't have an exponent that's negative or 0.
Last question, everyone, make it count.
Good job, guys. Most of you got it right. Well, we're done with this Kahoot, so it's okay. The timer can be a little longer.
Okay, let's see, what else do we have? Least common multiple and greatest common factor.
Do we have time to get through the whole thing? It's 24 minutes.
I don't know.
Well, we can always end it early. We'll leave 5 minutes to explain the rest of what we need to do.
Or should we do the 9-question one?
Oh. Okay, yeah, let's just go ahead and do the 9-question one then.
I mean, that one is word problems, so.
Yeah, that'll probably be the one, right? Go
I
Paul.
think that would be like fine for the rest of the class.
All right, anyone else want to join?
Akshat is saying that he can't join.
Maybe people can't join after the game starts.
I'm pretty sure you're supposed to be able to join after the game starts.
Okay.
Here, let me give you the
Right,
pin.
and if you can't by the end of this question, we'll just restart the thing.
There's the code if you need it. I think there are only 9 people, so. Yeah. So the answer was 30, and basically it's just asking for the greatest common factor between 120 and 30, and that's just going to be 30. Okay, so the answer is going to be 300, and it's just the least common multiple of 30 and 100. Oh, um,
I can read the question out loud if you guys can't see that. So Kelly has piano lessons every 4 days and voice lessons every 6 days. On the last day in August, Kelly had both piano lessons and voice lessons. In September, how often will Kelly have piano lessons and voice lessons on the same day? And there are 30 days in September.
Okay, so the answer here is going to be 2, and that's because the least common multiple between 4 and 6 is going to be 12. So every 12th day, she's going to have both voice lessons and piano lessons. And then there are 30 days, so 30 divided by 12 is going to be 2, and then like remainder 6. But the remainder doesn't really matter here.
Can you try like clicking on the thing and see if that will make it bigger?
Yeah, it doesn't do anything.
Oh,
I think you can like zoom in if you have like a mouse, you can. It's like Control Plus maybe.
It makes it
On
smaller.
don't need. Okay,
Oh,
it doesn't make the question any bigger.
well, I guess I'll just read it again. For field day, Mrs. Douglas puts students into teams, and there are 48 boys and 64 girls. Each team must have the same number of boys and the same number of girls. All students must participate. What is the greatest number of teams Mrs. Douglas can create?
All right, I'm skipping in 10 more seconds.
Yeah, so the answer here is going to be 16.
A bakery gave a donut to every 5th customer and a cupcake to every 12th customer. In one day, 8 donuts and 3 cupcakes were given to customers, which could be the number of customers the bakery had that day.
All right, 10 more seconds.
Yes, the answer is going to be 44.
Yeah, all right. I'm going to be skipping kind of fast.
Yeah.
We do have some other.
So the answer here is going to be 30, and that's because the least common multiple between like 10 and 6 is going to be 30.
Sorry if it kind of rushes you.
Yeah. So here it's going to be the least common multiple between 10 and 6, and that's going to be 30. So he'll need to buy 3 packs of 10. So therefore the answer is 3. Yeah, so the greatest common factor of 18 and 24 is going to be 6. All right. And in third place with 8 out of 10 or 8 out of 9, we have Australia, and then Dheeraj. And first is Charles.
Good job, guys. And now we're going to move to something I know you guys are going to love. All right, I promise. It's going to be so amazing. And
Yay, homework. So we will have a homework starting from today. So it's only 5 problems, and it's going to be posted in the Google Classroom, and it's also right here on this slide, and you guys will have access to this slide. And feel free to print them, make a copy, whatever you want to do, but please complete them before tomorrow's class, since we'll go over the answers tomorrow.
Here's the link.
If here's what it looks like. It's just a worksheet. You can make a copy of it.
I sent the link in the chat if you guys want to see it. Yeah, it's a Google Doc.
If it's a Google Doc, then how do we like turn in our assignment?
You can print it out and then like write on it, or you can just make a copy and submit it.
Wait, wouldn't it be easier if you could, couldn't you post an assignment on Google Classroom like
Yeah,
that way?
I think that's what we did.
All
I think
right.
I think an assignment's going to be posted.
Yeah, after class, I think.
All right. Does anyone have any questions?
It can be about how the class works or anything we covered today.
So I'm just wondering one more question about the homework. So we'll just type on the Google Doc, attach it, and then send it, right?
Yeah, you can even like you can like print it out. You can do anything with it, but just we need to see your answers. That's really it. You can like print it out and then like write on it with like a pencil and then take a picture and submit.
Okay.
Anything's fine for that.
All right. If you don't have any questions, you are free to go. Thank you guys for coming and participating. And be back tomorrow at the same time. Same link, same time.
Okay, bye.
Bye.
Bye, guys.
Bye.